Lesson 1.7. What lesson 1.7 is an introduction to functions. So what we're going to talk about is what makes it a function, okay? So we're going to need to write down the definition of the word function, and then we're going to write down the definition of domain and range. Those are pieces in an equation that would make it a function. Okay, before we talk about the definition of a function, okay, I want to talk about the domain and range because these are pieces of the puzzle that make an equation a function, okay? Domain is always x, or it's the input value. Sometimes it may not be the letter x, but it's what you would input into the equation. That's our domain. The output is our range. So once you've inputted the number into the equation, you'd solve the equation, and the answer or output that you get is our range. Now, usually that's represented by the letter y. So an example of an equation that would be a function would be something like y is equal to 2x plus 3. I know that x is my domain. I'm going to input a number into the equation. See how that is? I'm plugging it into the equation, so that's my input. Once I solve all of this, the output is my range, or the output is the same thing as the answer. It's once you plug a number in, you do the work, and this is your output, whatever that may be. So for instance, let's say I plugged in 2 as my input. That means I'm going to plug in 2 for x, so I say 2 times 2 plus 3. And whatever my answer is going to be would be my output. So 2 times 2 is 4, plus 3 is 7. So my input or my domain is 2. And my range is 7. Okay? That's part of your equation. Domain is your input, and it's usually the letter x. Range is your output, and it's usually the letter y. Now let's look at the definition of the word function. The word function means for every input, so that's my domain or the x value, there is exactly and only one output. So for instance, look right there. When I plugged in 2, is it possible for me to get any other output or answer other than 7? No, because that's the right answer. I'll never get 6. I'll never get 5. So for the input of 2, there is only one output because it can't be anything else. It does not equal anything else, okay, once you plug it into the equation. So this problem is a function because for the one input of 2, there's only one possible answer, okay? That's what makes it a function. For every input, there's only one output, okay? So let's look at our first example, and it says, does the table represent a function? So they've given us a table. They want us to say, yes, it is a function, or no, it's not. Okay, before we get started and you tell me, yes, it is a function, or no, it's not, let's look at the word input. What are 2 other options I could say instead of the word input? What could I call input? What's another name for it? Javen?
Range. Oh, wait, no, domain.
Domain, very good. Domain is your input. What's the one other thing that input can be? What variable? Madison? X, very good. Now let's do the same thing for output. What else can output be called? Range. And also, what letter can represent output? Clay?
Y.
Y, very good, okay? So I know my input and output, so I know in order for this to represent a function, for every input, there can only be one output. So let's go down our chart and let's look. For the input of 2, my answer is 5. How many answers does 2 have? 1, just 5. Okay, so far so good. For the input of 3, what is my answer? 10. How many answers does 3 have? 1. Just 1 10, okay? Now look at this next one. 4 is listed twice in my chart. How many outputs does 4 have? 2. So this is not a function. Because if it were a function, 4 could only have one possible answer. And look at this chart. 4 has 2 possible answers, 11 and 17. So whenever we say no, I do not just want you to write no. I want you to tell me why it's not. Because if you write no, I've got a couple different options. You know what you're talking about and you just didn't want to write it. Number 2, maybe you just got a lucky guess. You got a 50-50 shot of getting it right, okay? And then number 3, maybe you got the answer from somebody else. So I want you to tell me why you think it's no. So who can give me a sentence, or does it just a little statement of why it's no? Javen?
No, because 4 has 2 outputs.
Perfect, no. Because 4 has 2 outputs. Perfect. That shows me you know what you're talking about. You know that a function, for every input, it only is able to have 1 output. And you actually know what the problem's talking about because you told me the specific input that has 2 outputs. So that's perfect. Okay, now let's look at this second one. This is the one that really confuses people. So if you are zoned out, I can almost promise that you're going to be confused on this one. So I want everybody to pay attention, everybody to listen, and let's look at this chart. Most people look at this and say, oh, look at all those 5s. There's no way that this is a function. But remember, in order for it to be a function, the input can only have 1 answer. It doesn't mean other inputs can't have that same answer, but it's only allowed to have 1 answer. So let's look. For the input of 1, what is the answer? 5. How many answers does 1 have? 1. For the input of 2, what is its answer?
5.
How many answers does 2 have? 1. For the input of 3, what is the answer? 5. How many answers does 3 have? 1. For the input of 4, what is the answer?
5.
How many answers does 4 have? 1. So is this a function? Yes, it is. And why is this a function? Darius?
Because they all have different inputs.
For every input, there's how many outputs?
1.
Very good.
Oh, yeah.
For every input, there is 1 output. Okay, that is the difference of a function. Now I'm going to write this one down and I just want you to tell me yes or no. You don't have to write it down. Now look carefully, this is tricky. Is this a function?
Yes,
Yes. And why is it a function, Javen?
because 2 has the same output.
Exactly. Even though 2 is listed twice, what is the output of 2? 7. It didn't change. Now, if that was 2 different numbers, then it's not a function. But because it is the same, it still only has 1 output, even though it's listed in a different spot. Now, I'm not going to give you one like this on your test, okay? I just wanted to show you. Even if it was listed in 2 different places, it doesn't necessarily mean it's not a function. You've got to look at the outputs, okay? So just make sure you keep an eye out for that in case you run into it, okay? So now we're going to put this into practice, okay? They've given us 2 different equations, And they want us to make an input-output table using 0, 1, 2, and 3 as the domain. So what letter is 0 through 3 going to go in for? X, because it's our domain. All right, so I'm going to label my input-output table as X. And Y. Instead of writing the words input and output, because I know that those are the variables that I'm going to plug a number in for, and then the variable that's going to give me the answer. If you want to put input and output, that's fine. If you want to put domain and range, that's fine, because all three of those terms are able to be used interchangeably. So I've got 0, 1, 2, and 3 that I'm plugging in for X. How do you think I'm going to find Y? But am I just going to guess? Am I just going to say, oh, maybe 5 sounds good. Maybe 10 sounds good. All right, Matthew, what would I do?
You would solve the equation by plugging X into the problem.
Very good. I'm going to plug in 0 for X into the problem and solve for Y. And then after I do that, I'm going to do the same thing for 1 and 2 and 3. So what I'm going to do is I'm going to write the problem. Y is equal to 4 plus 2, and then instead of writing the X, I'm just going to plug in the 0. Remember, order of operations. If you do not do the order of operations correctly, you will get the wrong answer. First step, what would I do? Would I do 4 plus 2, or would I do 2 times 0? Madison? Which gives me 0. Perfect. 2 times 0 is 0. Then plus 4 is 4. Do the same thing for 1. Go back to the original problem. 4 plus 2 times 1. All right, Megan, what would I get for this problem?
6.
Very good. All right, the third one. Y equals 4 plus 2 times 2. What would I get as my answer for that, Darius?
10.
Think again. Oh, no, you're right. 2 times. No, you're not.
For which one?
For the third one.
So
2 times 2 is, I think you were doing the last one, Darius.
Oh, yeah, I was thinking of 3.
Okay, so if I plugged in 2, what should I get?
You'll get 8.
8. Very good. And then lastly, I'm going to get 10 because 4 plus 2 times 3, 6 plus 4 is 10. Okay? Now, if you notice, what I did is I showed my work. There wasn't a whole lot of work to show. I just at least said, okay, this is what I want you to say. I want you to plug in the variable or the number for the correct variable. So I at least know, okay, they know what letter this number is supposed to be plugged in for. And you can just write your answer in the chart. You don't have to do all the work and solve it out. Okay, this next one, I want you guys to do this next one on your own. Make an input-output table, do the work, plug it in for Y. Okay, so if you make your input-output chart, you have X and Y. Got a lot darker. What are the numbers that I was going to plug in for X? Clay?
0 for 0, Y, you would plug in 0, which would add.
Hold on one second. Just tell me what the X values I'm supposed to plug in. So 0, 1.
0. What?
Just the X values. What X values am I supposed to use in my chart?
0, 1, 2, and 3.
Perfect. Very good. Okay, Clay. Now, when you plugged in the 0 for X, what did you get for your Y?
I got 0.
Very good. So we had Y equals 3 times 0. Okay, Anna, what did you get when you plugged in the 1? Perfect. Okay. Jasmine, what did you get when you plugged in the 2?
6.
Very good. Jacob, what did you get when you plugged in the 3?
9.
Very good. Okay, here's our input-output table.